So, wish you very good morning to all. Welcome in our physics. So, we will continue chapter number 4, that is light, reflection and refraction. So, as we have already begun our chapter and most of the topics related to the refraction we have completed. So, I want to revise quickly. Even I will go with the PDF presentation, PPT presentation. In that, if any point is missing, that also we will try to cover. So, here the topics we have discussed in previous videos, in that spherical mirror. Spherical mirror. So in that we have two types of spherical mirrors. First is a concave and a convex. Even we have plane mirror also. So but we will discuss only for concave mirror and convex mirror. So here we will continue the spherical mirror, concave and convex. So concave and convex mirror we discuss in the image formation. The concave mirror will give us real and inverted, and convex mirror will give us virtual and erect image. So that two things you have to remember. Next we discuss about the image formation by spherical mirrors. Image formation by spherical mirrors. So in that we have two mirrors, concave mirror and convex mirror. Even we have discussed the uses of concave mirror and convex mirror. So same thing with the help of PPT presentation I will continue after completion of this board work. So then we will have some brief introduction, brief discussion about these topics. And after that we discuss about the new Cartesian sign convention for spherical mirror. So then in that we discuss that it depends on the distance. So it depends if it is minus side, so the distance object is minus. Okay, if it is plus side, so it is positive. So positive and negative. So that two things of the new Cartesian sign convention for spherical mirror. And after that we discuss mirror formula. So mirror formula was 1 by f, means 1 upon f is equal to 1 upon v plus 1 upon u. So this is a mirror formula. When we discuss about mirror formula, f is a focal length, v is the image, and u is the object. Okay, so this you will remember. And magnification m is equal to h2 upon h1. So the height of object, height of image and height of object. So that will be v upon u, but it is a minus. So two things you will remember here. Mirror formula will come, that is plus 1 upon v plus 1 upon u, and the magnification of mirror, so that is minus v upon u. Okay, so two things you will remember about these topics, magnification and mirror formula. Even new Cartesian sign, concave and convex mirror, image formed by spherical mirror, in that 6 position according to the position of the image, then nature of the image and the size of the image. That tables we have discussed. So from that you can prepare. So concave and convex. In convex only two there. So two positions they have mentioned. So that will easy for us. And uses of concave and convex mirror. So these are the topics related to our reflection in that spherical mirror. So I am turning to the another topic now that is very much crucial on page number 230. So we'll come to the page number 230. Page number 230. So in the page on the page number 230, so you can see the topic, that is refraction of light. So up to what we discussed, that is for reflection. What we discussed, that is of reflection. Now we are going to discuss the topic, that is refraction. So refraction, you know that it is the bending of light. Bending of light. from one medium to another medium. So when the light will pass, so bending of light from one medium to another medium. So when the light will pass from one medium to another medium, it will bend, and that we call as a refraction. Okay, so here you can see one diagram in the textbook also. The diagram is 4.29 that you can see, and the phenomena of bending of light from one medium to another medium. Now suppose this is a ray, we call as an incident ray. So incident ray from medium 1, so we can consider this is the air medium. Okay, so here air is a rarer medium. Air is a rarer medium, and this we take as a water or any other thing we can take. So water, or we can take glass also. Even we can take glass also. So here first medium and the second medium. So when incident ray, the light will pass in the form of incident ray from one medium, that is a rarer medium, to dense medium. So this is a denser medium. Denser. So this medium number 2 is denser, and medium number 1 is rarer medium. So here we can define the refraction of light, the phenomena of bending of light at the interference of two media, because two media are there. Media means medium, and when it passes from one medium to one transparent medium to another transparent medium, the opaque medium will be there, light will not bend. So remember this, the word which is given here, that is transparent medium. So light will pass from one transparent medium to another transparent medium, or we can say that the light will bend at the interference from one medium, one transparent medium, that is rarer medium, to another transparent medium, that is denser medium. Clear? So what is rarer and what is denser? So air we can say that is a rarer medium, and glass or water or any other liquid, so that we consider as a denser medium. So here two mediums are there. Air is a one medium, glass or water is the second medium. So both are transparent medium. So here the bending of light at the point of interference passes from one medium, one transparent medium, to another transparent medium. So that is called refraction of light. Okay, so you can understand. Now here, so here this is a light. So it will come in the form of incident ray, and this is a plane surface, plane medium we can say, or the same medium. So here incident ray will come in contact with another medium. So that what will happen? So light will bend. So here you can see that the light will bend in the second medium, not in the first medium. So here it is an incident, and this as a refracted ray, not reflected, it's a refracted ray. So IR, that we can understand, that is incident, and RR, that is for refraction, not reflection. Please be clear, when two mediums are there, so it is a refraction. If one medium is there, it is a reflection. So please clarify this, please try to understand. So when the light will pass from one medium as an incident ray, at the point of incident, the light will bend towards another medium, in the another medium. So that we call angle R and angle I. I for what? Angle of incident, and R for angle of refraction, and R for angle of refraction. So here you can understand, and this is for medium 1. Now I want to explain about these two words. If you see V1 and N1, so we call as a refractive index. So this sign we are taking as a refractive index eta. Generally we are writing like this eta. Okay, so it is 1. So 1 medium eta, or N generally you can write. So N1, so that is the refractive index, you can see here. So V is a speed. V is a speed. So here V1 N1 and V2 N2. So it depends on the medium. If it is the speed will be the refractive index will be in the medium 1, so it is V1 N1. And if it is in the medium 2, it is V2 N2. Okay, so this is about the refractive index. You can see in the textbook also. So refractive index, the formula, equation you can write like this. So N is equal to C upon V. So if you see on the page number 231, the speed of light in vacuum, that is C, and the speed of light in medium. So this is for the speed of light. Speed of light in vacuum, and speed of light in medium. Any medium, suppose medium is a glass. Okay, so here first speed of light in vacuum, that is C, and speed of light in medium, that is V. So C upon V. So N, that is the refractive index, C upon V. Now if you know that the speed of light in vacuum or air, so that is 3 into 10 is to 8 meter per second. So you can see in the textbook also. So the speed of light in air or in the vacuum. So if you see page number 230, the speed of light decreases when here second paragraph we can see. We know that the speed of light is maximum in vacuum and it is equal to 3 into 10 is to 8 meter per second, and the speed of light decreases when it travels in another medium other than vacuum, so it will be 2 into 10 is to 8 meter per second. So all students, please remember this. So it is the speed of light in air, and this is in medium. Medium, suppose glass there, water there, or any other thing. Okay, so this is the speed. Please remember this. The speed of light in air or vacuum, that is equal only. So that is 3 into 10 is to 8 meter per second. And the speed of light in medium, whether it is glass or water. So it is 2 into 10 is to 8 meter per second. So here the speed will decrease. If you see, here the speed is more and the speed is decrease. Understood? Because when light is bending from one medium to another medium, and that's why it, if you not propagate, the word here is in propagate also. So when it coming from one medium to another medium, light will bend, and because of bending of that, speed of light in the medium will decrease. Alright? So this is about the refractive index of optical medium. So here one word there, optical medium. If you see the word optical medium, optical medium. So optical medium is what? So here any transparent medium in which light can travel, in any transparent medium, glass there, water there, even air there. So the transparent medium in which light can travel, it is known as optical medium. It is known as optical optical medium, and the speed of medium in different mediums are different. Suppose if you see the speed of light in air, as I have mentioned, that is 3 into 10 is to 8 meter per second, and in the medium that is different. Okay, it is different. So that is 2 into 10 is to 8 meter per second. So that is for the refractive index. So then if you come to page number 231, the speed of light in glass, that is 2 into 10 is to 8 meter per second. So the refractive index can be calculated, that is N G for glass. So therefore you can keep the speed of light in air and divide by speed of light in glass. So 3 by 2, the power that is powers are same, so that's why it will remove. So 3 by 2 will come. So almost it is 1.5. It is 1.5. So we can say that the speed of light in a glass, that is 1.5. Okay, so 3 by 2 also we can write. So different absolute refractive index of different media, it is given on page number 231. So air, that is 1, refractive index, that is very less, 1. Ice, that is 1.31. The same thing, method is same. 3 by 2 means C upon V, C upon V. So speed of light in vacuum or air and the speed of light in medium, the particular medium is given. So according that in alcohol it is 1.36. Now highest refractive index, the highest refractive index you will observe in a diamond, that is 2.46. 2.46. So 2.42. It's a 2.42. Highest refractive index is any of the material, any of the medium, any of the material medium. So that is diamond. So in exam they can ask which is the material which has the highest refractive index, that is diamond, 2.42. Okay, so this is about the refractive index, and then if you see the factor on which the refractive index of medium depends. First is what? The nature of the medium, what type of medium it is, whether it is a rarer medium or a denser medium. Second is what? Optical density of the medium, and third is wavelength or color of light entering into the medium, which type of color is entered so in the medium. So there are 3 factors. First is the nature of the medium, second is density of the medium, and fourth is the wavelength or color. So all 3 factors depends upon refractive index. Got it? So once again, the 3 factors affecting the refractive index depends on. So the first is we can say nature of the medium, what type of nature of the medium. Second is what? The nature, the optical density of the medium, and third is the wavelength or color of the medium. So if you come to the page number 232, you will say the relative refractive index. You will come to this topic, relative refractive index. Now relative refractive index, in that mediums are there. If I will take, I think you will be clear in this, so I am erasing now. So here, the relative refractive index, just remember this, we are having 2 medium. So in that N12. N12 is equal to N2 upon N1. N2 upon N1. Now, what is N2 upon N1? So, here we can say the speed of light in the medium 1, the speed of light in medium 2, and speed of light in medium 1. So, N2 is what? For the medium 2, and N1 is for what? Medium 1. So, here the same thing, if of light in one medium and speed of light in second medium. So medium 1, medium 2. So here we can write V1 and V2. Clear? So and that is a medium 1, N2 that is medium second, and V1 that is the speed of light in medium 1, and V2 that is speed of light in medium second. So here by understanding the refractive index of medium 2, so here N12 is equal to N2 upon N1, N2 upon N1, whereas we have proved that N is what? C upon V. So here medium is same, medium 1 is same because it is air only, but second medium will change. Second medium will change. So here we can write C upon V1, and another thing we can write, that is this is for 1 and N2. So it will be C upon V2. Okay, so these two for the refractive index. So N1, this is for the medium 1 and this is for medium 2. So C upon V1 and C upon V2. So therefore, if you keep this value here, you will get N12. So that will be V1 upon V2. That will be V1 upon V2. You can see in the textbook also. The speed of light in the medium 1, V1 upon V2, and 12. And 12 means V1 upon V2. And 12. So means V1 upon V2, and N21, that is V2 upon V1. V2 upon V1, you can see here. Okay, so first is what? The medium 1 and a medium second. In medium 1 N12, that is V1 upon V2, and medium second, so N2 1, that is V2 upon V1. So here that will be V1 upon V2 and V2 upon V1. So now if you take example, the refractive index of glass, that is 3 by 2 and 4 by 3. So in that water and glass, so it is mentioned like this: water and glass. So refractive index in water and glass. So that is we can say VW upon V glass. So therefore it is 3 by 2 and this is 4 by 3. So you can see that it is already given. You can see the refractive index of glass. There is a relative refractive index of glass, that is N water glass. So N glass upon N water. So here same thing we can write. In that also we can mention N water upon N glass. Same thing. So here it will, if you know this, it will be 9 upon 8. 9 upon 8. And unit is not there. So the same thing in the water also, that is 8 upon 9. In the water it will be different, so it will be opposite. This is for the glass. If it is for the water, so this is for glass. Glass, the refractive index is 9 upon 8. If it is for the water, then it is 8 upon 9, opposite. It will turn. So like that. So here this is for the glass and this is for the water. So relative refractive index in glass 9 upon 8. So here 9 upon 8 and 8 upon 9. So for the glass 9 upon 8 and for the water it is 8 upon 9. So refractive index. Now next important topic, that is the last topic, then we will go for the PPT presentation. So laws of reflection of light. So I think you can understand what is the meaning of refractive index. N1 C V1, N2 C V2. Okay, and laws of reflection of light. So first is very clear, like a reflection, incident ray, refracted ray. Please mention that here it is a refracted ray and normal ray, all lie on the same plane. So therefore you can write the law of reflection first: incident ray, refracted ray and the normal ray at the point of interference of two transparent medium at the point of incident all lie in the same plane. So here you have to add one bar, two medium. So once again, the normal ray, incident ray and refracted ray to the interference of two transparent media at the point of incident all lie in the same plane. All lie in the same plane. Here also all lie in the same plane. Second is what? It is little bit different than reflection of light law. So here the ratio of, you can see that the ratio of, this is second one, sin I upon sin R. So ratio of incident, angle of incident and angle of refraction is constant for the given pair of media in contact and for light of given color. So remember this simple thing, you will remember. So sin, we can say that here the ratio of sine of angle incident, the ratio of sine of angle incidence and sine of angle refraction are constant. Okay, so here you see that is n2 upon n1. So this is for medium 1 and this is for medium second. So therefore medium second we can mention this and medium 1 we can mention this, n2 upon n1. So the same way the ratio of sine of angle of incident to the ratio of sine of refraction is constant. So this is the second law of refraction. First law of refraction is very common because it's the same like reflection, and second is little different as compared to reflection. So here sine of angle incident is we can say the ratio. I am using the word ratio. The ratio of sine of angle incident and sine of angle refraction is constant. So n2 upon n1. So therefore we can write this 1, 2. What? 2. Clear? So this is about the laws of reflection. And if any topic is remained, that will continue the PPT presentation. Once again, just we are revising quickly the refraction of light, the bending of light in that two mediums required, medium 1, medium 2. Incident ray coming in contact with second medium, light will bend, and that angle they will form, that is refraction, angle of refraction. And next we have discussed refractive index. Refractive index is what? So it is a speed of light in vacuum upon speed of light in medium. So here if you see the refractive index of a medium is defined, the ratio of speed of light in vacuum to the speed of light in medium. So it is represented by n or eta. Okay, so that you can remember. And the speed of light in air, that is 3 into 10 is to 8 meter per second and 2 into 10 is to 8 meter per second in medium. Next we discuss relative refractive index. So in that n12, so n2 upon n1, and if n21 then it is n1 upon n2. The same way for this speed, v1 upon v2, v2 upon v1. Then next to the laws of refraction of light. In the first law it's very common, and the second law, so sin I is equal to sin I upon sin R is equal to constant. So that we are continue with the PPT presentation. So please continue